Alright, in this video we're going to look at solving linear inequalities. Um, so on the left here I've got an example of a linear equation. So it's linear because the highest degree on any, or highest exponent on any of the variables in the equation is 1. Right? And it's an equation because there's an equal sign. On the right I've got an example of a linear inequality. It looks very similar. The only difference between these two things is this one has a greater than symbol as opposed to an equals symbol. So an inequality means you're dealing with greater than symbols, less than, greater than or equal to, less than or equal to. Okay, so that when we say inequality, we're talking about one of these things. Now, how are you going to solve this? Well, first I'll just solve this equation, and we'll see how you solve the inequality almost the exact same way. So if I was solving this equation, I have a minus 1. I want to add 1 to both sides of this equation. These will cancel. I have 2x equals 3 plus 1, 4. Divide both sides by 2. So x is equal to 2. So when we solve an equation, we get an exact number. At least when we solve a linear equation, we get one solution. You know, when you solve quadratic equations, you can have 2 solutions, cubics, 3, etc. But for linear equations, you're going to have exactly one solution. When we solve the inequality, we're going to do the exact same thing. We can add 1 to both sides of this inequality, and the inequality will still hold, right? If you have something here that's bigger than something here, well, if I increase them both by 1, the thing on the left is still going to be bigger. So 2x is bigger than 3 plus 1, which is 4. Now I can divide both sides by 2 in the same way, and for the same reason. If you have two things, one is bigger than the other, and you cut them both in half, then the bigger thing is still going to be bigger after you divide it by 2. So x is bigger than 2. So notice that our solution is itself sort of an inequality, and its solution, or the solution, means there's multiple values of x, which will make that original inequality true. Remember, the original inequality is this. 2x minus 1 is bigger than 3. So what this is saying is that any number bigger than 2, if I put that in for x, would satisfy this inequality. So we actually get a whole set of numbers. You could think about this answer or this solution on the real number line. So if this were our number 0, and 1, 2, so we use a different color. So we're saying any number bigger than 2, so not including 2, but anything to the right of 2, any number here will solve our equation. Or you could write your answer in set notation. You could say x is an element of the set, or the interval going from 0, I shouldn't have a comment there, from 0 to 2. So you could also kind of check your answer as check. Try a number bigger than 2. Try x equal 3, right? 3 should satisfy this equation. So if you went with your left side, you'd have 2 times, well, let's write the whole thing. 2x minus 1 would be 2 times 3 minus 1, which would be 6 minus 1, which is 5. Compare that to your right side, which is 3, and notice that 5 is bigger than 3. Since left side is bigger than right side, the inequality holds, or the inequality is true. For x bigger than, or sorry, for x, we only actually tried one value, for x equals to 3. Now obviously there's a lot of numbers that are bigger than 2 that you could check, but you're only going to be able to check, at most a couple. But usually, if you, assuming all the steps went right, uh, checking one point in this interval is probably good enough. And a lot of times you maybe won't even check any, but just for reassurance, just to see what's happening, it can be a good idea to check a point. But it should work with any number bigger than 2, right? If I took x equals to 4, I should get left side bigger than right side. Anything bigger than 2. Okay, let me try one more example. So let's solve. So you're going to be asked to solve inequalities much in the same way you were asked to solve equations. So 5x plus 3 bigger than or equal to 10. You're going to solve this the same way you would a let's not write it like this. I'm just going to write it how probably most people would write it. So I'm going to subtract 3 from both sides. So 5x is bigger than or equal to 7. And then I'm going to divide both sides by 5. The 5's reduced. So x is bigger than or equal to 5 over 7. So any number bigger than 5 over 7. If you wanted to write this in set notation, you'd say x is an element of the set. And now we have to use a square bracket because we're including the number 5 over 7 all the way up to infinity. Infinity always gets a round bracket. Or if you wanted to illustrate this on the number line, putting this on the number line, it might help you to know, like 7 over 5, where does that fall on the number line? Well, 7 over 5 is equal to 1.4. So if this is 0, 1, 2, 3, changing colors, 1.4 or 7 over 5 is about here. And we want a solid circle, or a solid dot, because we're including this. We're saying anything bigger. And then because it's a decimal, or it's hard to see, I might just want to indicate what that number actually is. So this is 7 over 5. Just so I can see exactly where it starts on my number line. So illustrating either in like this with your greater than less than symbol, like this in your interval notation, or like this on your number line, or you could even go to set notation. The set of all x such that x is bigger than or equal to 7 over 5. And it's assumed there that x would be a real number if you don't state otherwise.